a big part of this class is working with measurements. We'll be taking measurements. We won't be actually doing the measurements because this is a lecture class, but be given measurements. We'll have to be working with those measurements in calculations. So we're going to be looking at starting with the units of measurements, because a measurement has two parts. It's got a number and it's got a unit associated with it. So we're going to be looking at those together. We're going to start with looking at the units of measure, and then we're going to examine mass and weight, and then volume today. All right, so SI is for the international system. It's French, so it's backwards, but that's what SI is. And we'll, for the most part, deal with SI units in these. It's based upon the metric system, but it is more fine-tuned than just the metric system. So here are the, what we call base units for measurements, okay? I'm going to assume that you feel pretty comfortable with length and time. You've been measuring length for a long time. You have been measuring time, and you're probably measuring it right now, wondering how long this thing's going to last, okay? So length and time, we really won't spend a lot of time, assuming you have a pretty good feel for length and time. And so those are why the asterisk is there. Some of the other units of measurement that we'll talk about after I kind of look at this table are based upon deriving out of these. So all the SI units will have a derivation, because you'll see that this list leaves out a lot of things. We don't see volume on this list anywhere, do we? So we'll examine mass here in a little bit, and we will examine temperature in a little bit, not in this lesson, but in our next lesson. But let's look through the list. I said something about mass. Electrical current, we won't talk about electrical current until, gosh, much, much later. It won't be in General Chemistry 1. It won't be until General Chemistry 2. We see the temperature scale there, and the SI unit for temperature scale is Kelvin. We'll examine eventually the Fahrenheit scale and the Celsius scale and the Kelvin scale. The amount of substance is mole. The thing I want to mention here about a mole is its abbreviation. Woohoo, you get to leave off one letter when you abbreviate a mole. It is kind of a pet peeve of mine that I don't like people abbreviating mole with an M. They think that's a much better abbreviation, but M stands for meter, and we don't want to abbreviate a mole with an M. Candela is not a unit of measure that we will use at all in general chemistry. So this is the basis of all the SI units. But like I said, there's a lot of things left off of here. But let us then look at our SI prefixes. This is kind of a lengthy list, and you are going to have to memorize this list of metric prefixes. What you have to memorize is the prefix word, okay, so the word tera. You need to be able to know the symbol T. You need to memorize what it means, its meaning. See, it says meaning there. I memorize it typically in this format. 10 to the 12th means you have those 12 zeros there. And then we see this example, and I want to spend a little bit of time and do a little bit of writing about what that means, okay, and how we would work with that. But before I do that writing, let's look at the ones that are the most common. These ones that I have an asterisk next to are the most common prefixes. You will use them more frequently than all the other. In chemistry, General Chemistry 2, we might spend a little bit more time with the nano or the picometer, for example. But for the most part, as you're working through problems, you're going to see these. Now, that doesn't mean you don't have to know them all, but you'll get really familiar with the ones that I have put an asterisk next to, because you will use those more frequently. So I just want to spend a bit of time talking about what we see here with the example. And I want to start with milli. If you look at there at the definition of milli, it tells us that milli is 10 to the minus 3, right? 10 to the minus 3. So if we have that memorized and then we have to use it, a lot of students don't really have a good feel for how to use that. So what I want you to do is to think of this meaning as if you had the, let's say, a millimeter, okay? What that would be equivalent is to take your meaning 10 to the minus 3 of that base unit meter. So 1 millimeter is 10 to the minus 3 meters. Now, I will always use this relationship as we work through problems, written this way. What many of you learned in a former class, maybe in high school, is to do this. It takes 1,000 millimeters to equal 1 meter. That is a true statement. But if you do it this way, you find yourself getting confused in later places where you've taken your meaning, what you know, and trying to translate it. Here's another example. Let's do kilo, okay? So all of this was about milli, okay? Kilo. Kilo has the meaning of 10 to the positive third. Okay, so what does that mean? If I had 1 kilometer, okay, or 1 kilogram, it would equal 1,000 of that base unit meter. 1 with the prefix equals the meaning without the prefix. 1 with the prefix equals the meaning without the prefix. So while this is a correct statement, and you would never get it counted wrong for doing that, I will always consistently put the 1 where I see a prefix and what it means where I have just that base. Let's do one more example. Let's take micro. Okay? Micro. Here's our symbol for micro. Okay? 1 micrometer, that's how we would say it. 1 micrometer equals, well, what does micro mean? Eventually, you'll have this memorized, but micro means 10 to the minus 6. So 1, where I see the prefix, is 10 to the minus 6, where I just have its base, 10 to the minus 6 meters. So 1 micrometer equals this. So if you will always follow that pattern, putting a 1 where the prefix is and its meaning where you've left off the prefix, you will have a perfect relationship of each one of these prefixes to use in calculations in the future. Okay, so let's examine mass. Okay, let's look at some of these definitions here. The unit, SI unit for mass seems kind of strange. It is a kilogram, okay? The SI unit is a kilogram. It seems like we ought to be able to leave off the kilo prefix. But the reason that they do that is basically in most areas of science, a gram is so tiny, and a gram is about the mass of a paper clip. It is so tiny that they don't use it for most sciences. Now, we love to use a gram in chemistry, but what does it mean? Well, we know that kilo means 1,000, okay? So 1 kilogram, and I've put a 1 where I see the prefix, is equal to 1,000 grams. Now, a lot of times we use the term weight and mass interchangeably, but they really mean different things. Weight is how gravity acts upon that matter. So mass is just how much matter is there, and that's not going to be that's going to be the same whether you're here on planet Earth or you travel to the moon. The quantity of matter is not changing. So the mass can't change as you go to the moon. But weight is how gravity acts upon that mass. So you will weigh differently here on planet Earth than you will weigh on Mars. Or let's go to the moon. Let's not go to Mars. On the moon, okay? So that is weight. They're measured differently. Mass is measured with a balance. When you balance it out by putting weight on opposite sides. So that is how we measure mass. Weight is measured with a spring. So you have a spring and you're pulling down on that spring and you put it in there, and a little lever will go up and down and tell you how much weight it has. And gravity will pull harder depending upon where you are. Now what we do is we define the relationship between these two with a constant, and this constant is defined as a 1 here on planet Earth, okay? So on the moon it's about a tenth of what it is here, so you would weigh about a tenth of what you weigh here on the Earth. You're not getting skinnier, you're not getting less mass, but you are weighing less. So a kilogram bar is a kilogram bar, whether you're here in terms of mass, whether you're here on planet Earth or on the moon. But if you go to the moon, it would weigh a tenth. Now let's look at volume. Now volume is a derived unit. So volume equals length times width times height. We've learned that somewhere along our way. So it's got the length unit, a length unit, because we're measuring length for all three of those, and since the SI unit for length is meter, it would be a meter times a meter times a meter, or a meter cubed. So that's the SI unit for volume. Now that's pretty big. We rarely would work with a cubic meter of any chemical in chemistry, okay? We typically would get it down in the scale of a cubic centimeter instead. So a cubic centimeter is 1 centimeter by 1 centimeter by 1 centimeter, okay? And a centimeter is 10 to the minus 2 meters, so that's 1 centimeter, okay? And if we cube that, we will actually get 10 to the minus 6 cubic meters, okay? So that is what a cubic, 1 cubic centimeter is. So if you were to think about a sugar cube, I don't know if you've ever been around a sugar cube, but the size of a sugar cube, so you have this little cube here, a little sugar cube, that's about a cubic centimeter. Very small. That's usually the amounts that we work with. Another unit that we commonly use in chemistry is the liter. This is not an SI unit, but we still use it a lot in chemistry, okay? 1 liter is 1,000 milliliters, or we could say 1 milliliter is 10 to the minus 3 of the liters, okay? And so we see some connections there. The one connection that I like to make sure I put in my mind and use to get between a world of length cubed, which we see here, and the world of the liter is I have this one that I commit to memory. 1 milliliter and 1 cubic centimeter are the same. That way, if I'm working in a problem and they're dealing with liters, but I need it in a cubic length, like cubic centimeters, I will be able to use this relationship to get me between those two. So I've put a blue box around it. I generally put blue boxes around things that you better commit to memory. So that is the SI unit, cubic meter for volume. We rarely use the SI unit of cubic meter. We will more commonly talk about liters, we will talk about milliliters, and we will talk about cubic centimeters.